Namaste dear students. This is my video tutorial on the topic graphical representation of motion from motion chapter of ninth standard. In this video we will learn different types of graphs to represent the motion of an object. Here we would study two types of graphs: distance time graphs, which are also called position time graphs, and velocity time graph or speed time graphs. First of all, we are going to discuss about position time graphs. As you can see on your screen, four different types of position time or distance time graphs are shown. Let's talk about the first graph. In the first graph, the graph line is parallel to the time axis. This type of graph represents the body at rest. Because the slope of the graph is 0, hence the speed of the body is also 0. Hence the body is at rest. The slope of distance time graph represents speed. In this graph there is no slope, so speed is also 0. Look at the second graph. In the second graph there is a straight line originating from the 0. The slope is positive, hence the velocity of the body is constant. Third graph. In the third graph the slope is negative, hence the velocity is constant but negative velocity will come. Fourth graph, the slope is a curve. That means velocity is not constant, means the object is accelerating. The steeper the slope, the higher will be the speed of the body. Thus it is important to note here that the slope of distance or position time graph indicates the speed of the moving body. The steep line indicates a fast steep, a shallow graph indicates a slow speed, and a flat line where there is no slope indicates 0 speed. That is, the object is stationary. How can we calculate the speed using distance time graph? Here is one example. In this graph, we have marked 2 points A and B. The object has moved 60 meters from A to B, and it took 3 seconds to move this distance. Now we know that speed is equal to distance upon time. So if we divide 60 by 3, we get 20 meters per second. In this way, using graphical representation, we can calculate the speed of the moving body. Next type of graphs are speed time or velocity time graphs. In these graphs also the time is taken on the x-axis, because time is an independent quantity and it is always taken on the x-axis. Velocity is taken on the y-axis. The slope of velocity time graph gives acceleration, while the area occupied under it will give us the displacement of the body. Let us talk about the first graph. The first graph is parallel to the time axis. When the velocity time graph is parallel to the time axis, it means the body is moving with the constant velocity or constant speed. In this case, the acceleration of the body is 0. So this type of motion is also called non-accelerated motion. In the second graph, there is a straight line originating from 0. This straight line of velocity time graph indicates uniform acceleration. That is, the velocity of the body is increasing by equal amounts in equal intervals of time. In the third graph, the line shows a curved path. This type of velocity time graph indicates non-uniform acceleration, means the velocity of a body is increasing but by unequal amounts in equal intervals of time. So this is the non-uniform acceleration. The last graph that you can see on your screen represents non-uniform retardation. Here the velocity of a body is decreasing but not with equal amounts in equal intervals of time. Hence this is the graph of retardation, that is non-uniform negative acceleration. Finding the acceleration. Velocity time graph can be used to find the acceleration of a moving body with the help of its slope. We know that acceleration is equal to change in velocity upon time taken. So the gradient of a graph will help us to determine acceleration. We can take the change in the velocity by considering any 2 points on the graph line, and the similar coordinates of time would be taken. This ratio will help us to calculate the acceleration of the moving body. Velocity time graph also represent one more quantity, that is the distance traveled by the body. The distance traveled by the body can be calculated by taking the area occupied by velocity time graph. As you can see in the graph appearing on your screen, that the area is shown below the graph line. This area represents the area of a triangle. Area of triangle can be calculated by formula half into perpendicular into height, half into perpendicular into base. Using this formula, we can calculate the distance traveled by the body